Hi, welcome to nETSETOS. In the last video, we discussed about how to insert node in linked list. Now we will discuss how we can delete nodes in linked list, whether it is in middle or at start or it is at end. First of all, let's know how we can remove nodes from the start. As here at the start, we have a node A. Here we have a variable head which is pointing to A. You need to note one thing whenever you have to delete from the start or from the end. As it is a linked list, it will have a single direction. Two nodes are connected singly. That's why it is known as singly linked list. The other one is doubly linked list where it is connected two-way, which we will discuss later. For singly linked list, if we have to remove from the start the first node, so it will be having just one connection. So if we need to remove this first node, we just need to break this connection. Same with if we need to remove the last node, as last node always pointing to none. We just need to remove the last connection. But when it comes to removing the middle node, then there we will have two connections. There we will use other strategy, but for first and AND node, there will be just one connection. So let's see how we can break this connection. So for start, we need to remove this A. So for this, we just need to point head is equal to head dot next. When head will shift to B, head always points to the first node. So this connection will automatically disconnect. That means B will be first node. Now let's see how we can remove node from the AND. So for this we need to reach at last, from where a last node has to be removed. So as to remove last node which is pointing to none now. This is none sign. So we will make such condition that this temp should reach to the second level. And when temp, our pointer, will reach at second last node, then we will put its next address as none. So this connection will automatically be broken and D will be our last node, which is pointing toward none. Now let's see how we can delete node from the middle. Let's say we need to delete C node. So for this, first we need to reach a node before C, because reaching at C will be useless. Anyhow, we need to delete this C. So we will ask our temporary pointer to reach the node before it. Node before C is B. So it will come here. After our temporary pointer is at B, it will ask B's next address to be 300. So instead of 200, its next address is 300. So instead of pointing to 200, it will directly be connected to D, whose address is 300. So these two connections will automatically be broken and B will be directly connected to D. So how simple it was. So let's understand this with the help of algo. If we need to delete node from start, we just need to follow these two statements where head is at A and we just need to write head should be head dot next. Head dot next is 100. So head will point to head dot next. As we know, head is always pointing to the first node of linked list. If head is pointing to B, so this connection is useless. That means this node will be removed. So for deleting from the start, these are the base condition, which are if head is equal to none. That means the first node, which is none itself. There is no node. So here only it will return. There is no need to go to rest of the program. Then the second condition, if head dot next, Let's say this is our A and it is a head, which itself says that my next is none. That means we have just one node in our linked list. So for this, we just need to delete this head. That's why head is equal to none and return here itself. Now let's see how to delete node from mid. Here we will be deleting C node and we have a variable head which is pointing to the first node, which is A, and we will take a temporary pointer so as to reach the location from where C node can be deleted. If we need to delete C, so for this we need to reach at B. So here there is a while loop which says move forward till you get a node before C. So here let's take the example as of D. We need to delete D. So for this our temporary pointer should reach C. Let's see how our algorithm will work for deleting D node. First statement, temp is equal to head. Our temporary pointer first is at head. Then it says a while loop where temp.next.data till it reaches D. So here temp.next.data. Temp is at A, temp.next is B. Is temp.next data is D? No. So it should move ahead. Temp is equal to temp.next. Now again it will look for temp.next.data is D. It is C over here. So it will again move temp is equal to temp.next. Now our temp is at C. Then again it will look for is temp.next.data. Here temp is at C. So it will ask temp.next, which is D now. So here it is not equal to. So this time it will come out of the while loop as we are on the node before D, which we want to get deleted. So it says temp.next.next. Temp is C, dot next is 300, which is pointing to D. Then D dot next, which is 400, and it is pointing to E. Should be temp.next. Temp.next is 300. So it says E's address should be on temp.next. So instead of 300, we will write over here 400. As C.next is 400, so here we will have a connection with 400. And it will break this all over connection and our C will directly be pointed to E. Now we will see how to delete node from AND. So for this, there is a variable head which is pointing to first node of the linked list, which is A. And here we will take temporary pointer which will move to the last node. Last node is E. So for here we need to delete E. Temporary pointer will move one by one and will reach a node before our last node, because the last node we have to delete anyhow. So let's analyze with the help of algorithm. So here we have temporary pointer which is pointing to head. So this is a temporary pointer. Then we will have a while condition that temp.next.next. With this we will get our second last node. So let's see temp.next.next. So temp is at A, dot next, which is 100, and 100 is pointing to B. B's next is 200 and 200 is pointing to C. So it is asking whether this is equal to none so that it can get its second last node. But here it is pointing to C. So it is in while loop. With this, temp is equal to temp.next. So we are asking temp to move forward. Now our temporary pointer is at B. Temporary is at B. Dot next is 200. 200 is pointing to C. And C's next is 300 and 300 is pointing to D. So temporary dot next is D here. It is asking whether it is none. So it's not none. Temporary pointer will push forward. So now a temporary pointer is pointing to C. C's dot next is 300. 300 is D. D's next is 400 and 400 is pointing to E. Temp dot next is none, but here it is E. That means it is not equal to none. So temp will move forward. Now this time it is at D. Here look it carefully. We have temp on D. So I'll write D. Dot next is 400. 400 is pointing to E. And E dot next is this time none. So this time it is asking whether temp dot next is not equal to none, but here it is equal to none. So this time a while loop will break and it will come out of the loop, and it says that temp dot next is 400 right now. It should go to temp dot next. So instead of 400, it should be none over here. So what will happen if it is none? That means this connection has been broken and D will be our last node. So this is how we can delete node from the beginning and from the middle. Now let's implement these all three algorithms with Python code. So here we are in PyCharm and I have written the same code for start, middle and for end. So first of all, let's run the program where we have 6 nodes. This time we need to delete a node. For this, we will simply write head is equal to head dot next, so that our head will point towards B. So let's run the program. So with this, our A node is deleted and we got the rest node B, C, D, E and F over here. Now let's see how we can delete node from the middle. For middle, we will delete D node. So for this, we have given our input in a parameter node to be deleted. So here we will give D. So I will go where calling has been done. Instead of node to be deleted, I'll write over here D. And with this, we will ask a temporary pointer, which is at head right now, to move a node before D here, and then it will make connection with E directly with this statement. So for this, let's run the program. So as we can see, here we got A, B, C and D is missing here. After C, we got E and F. Now let's see how we can delete node from AND. AND is F node. So here we will have temporary pointer which will reach a node before F and will give temp dot next. So here when we will have temp dot next will be none, so that this connection can be broken and we will able to delete our F node. So for this, let's run the program, and here we got node from A to E. The last node has been deleted with this way. So this is how we can delete node from start, mid and end. So hope you like this video. So please give a thumbs up to my video, and if you face any problem throughout this content, you can comment in the comment section, and do subscribe my channel. Thank you.
Thanks for watching. Drop a like. Leave a comment. And don't forget to subscribe.